This table is designed to give you the area to the left of a targeted z-score. And my targeted z-score is 1.15. Now, how do you know that this table is designed to give you area to the left? Look, it shades to the left of a z. What's my target? It's 1.15. So let me show you how to use the table. And we agree that the answer is going to be more than 50%, of course. So look, 1.15. Let me explain how to use the table. It's very easy to use. Pick the first two digits, the one before the decimal and the one after the decimal, which is 1.1. Look it up right here. So it's right here, 1.1. Now, what's left? The 0.05, the 100th decimal place. Pick it from here, guys. Any guess, guys, do you think how I'm going to find the answer? What would I do? I got the 1.1 and I got the 0.05.
Find where they intersect.
Exactly, find where they intersect. And they do intersect right here, guys. 0.749, 0.8749, and that would be the area. So again, 1.1, 0.05, they intersect at 0.8749. That would be the area. So area to the left is 0.8749. Okay, your turn, guys, and I'll project the table. I'm gonna ask you to find. You're gonna have lots of exercises like this when you do your homework online. It's a matter of looking it up in the table and getting the answer. So you can see this one, guys. It's the area to the left of negative 1.33. Let me show you the table. And let's see if one student can tell me what the answer is. So negative 1.33. Okay, look it up, guys, and tell me what the answer is. See, there's a one for negative z-scores as well. So what would be the answer, guys? Okay, I have some responses. Yep, 0.098918. Do you guys agree? Negative 1.33. So you looked at negative 1.3, and then you looked at the 3, and you got it right here, 0.098. I couldn't agree more. That is correct. Sometimes they will ask you to write the area as a percent. So if you change this one to a percent, guys, it will be 9.18%. It's a small area, 9.18%. Okay, next question. This is pretty much chapter 5, guys. It's not difficult, so you will see. Find the area to the right of z equals 1.23. To the right. So let me sketch it right here. Okay, to the right, so that's a 0. 1.23, so I'm going to just put 1.23 somewhere, guys, and a shade area to the right. All right, and I'm going to project the table and see what would you guys do to find this area. So here's the table. Since it's positive value, so I'm going to just project the positive. Remember, guys, this table is designed to give us areas to the left. So this is 1.23. And what would you suggest? Any ideas?
0.8907.
Okay, 0.8, so you read 1.23. Okay, let me see what you did. 0.8907. Do you agree with me that the answer should be less than 50%? Do you guys agree that what I shaded is less than 50%? Yes or no?
Yes.
Yeah,
Yes.
I mean, it's less than 50%, guys. But what you read through the table, it says 0.8907, which is more than 50%. Remember, the table only does areas to the what? To the left, but the question was to find the area to the what? To the right. So how can you use the 8.907 answer to find our answer? You will subtract it from 1. You subtracted it from 1 because the total area is 1. So in other words, guys, if he asks you to find the area to the right, if you want to use the table, you will use the table as you usually do, but you subtract the answer from 1. So it's going to be 1 minus 0.8907, and you do the subtraction. All right. So this is for areas to the right. And the answer will be always 1 minus 0.8907. Enter. All right. $23, yeah. So you get 0.1093. And that should make sense because the area is less than 50%. I mean, this is one way, guys. If you put 0.8907 and you want to check if your answer is correct, I would ask myself, I shaded less than 50%, but this answer is more than 50%, so I must have done something wrong. Well, you remember that the area to the left plus the area to the right, you always add up to 1. And this table, again, it's only designed to give you areas to the left. So in order to find an area to the right, you find area to the left and subtract the answer from 1. Okay, so that's 1. We're gonna do some more practice on this. All right. Next one. He wants me to find the area to the left. Well, I've already did the answer, but I'm just gonna show you the math. To the left of z equal negative 0.99. Okay. Well, probably a question you want to ask me, what about technology? It's coming. It's coming in shortly. Negative 0.99, guys. To the left. So you just use the table as is. Okay, so I need negative 0.9 right here. And then the 9, it's right there. Look, right here, that's a 0.09. So where do they meet? 0.1611. Watch. I got a 0.1611. Okay. Let's do this together, guys. Express the following as probabilities. Find the area to the left of z equals negative 0.47. Okay. Negative 0.47. I'm going to just sketch it right here, show you the table. Before I do the table, let me sketch it for you. To the left, this is the 0, negative 0.47. Just put it anywhere you want and shade area to the left. That's the area to the left. Okay, can you look it up, guys, for me? Let me see.
0.3192.
Let me see. So we got 0.1047. 3192. Yes, I agree. Does everyone agree with this answer? If you guys still in doubt on how to use the table, please let me know. Don't be shy of asking the question. So yes, it is 3192, guys. Yep. 4, 7. This is the 4, and this is the 7, 3192. Okay. I'm just going to put the answer now and then we'll fill out the rest. Find the area to the right of z equals 1.28. I'm going to sketch it first, just to show you what do I mean by the right. And 1.28, just put it here. And the area to the right. Okay, let me take you to the positive part of the table. And 1.28, guys.
.88.
So that's 1.2 and 8 goes right here. So 1.28. Do you agree? So I have 0.8997, but this is the area to the left. What I'm going to do with this one?
Subtract 1.
Yeah, subtract it from 1. So it's going to be, let me write it down, 0.8997. So it's going to be 1 minus 0.8997. And you can use your calculator to find this answer. Here you go. 1 minus 0.8997. It's all right. So 1.003. I'm just going to put the answer and then we'll fill out the rest later. Okay, now area between negative 1.1 and 1.73. This is in new. We haven't done in between, but let me see if students can pick this up. There you go. So negative 1.1, it has to be in the negative side. 1.73 is going to be on the positive side. We need this area, guys. Any ideas? How would you find this area? Think about it for a second, and I'll project the table to show you. Resume recording. He wants this area, guys. Look what you can do. You can find the area to the left of 1.73, which is going to be this. Watch, let me shade it. But I don't want all this area. I want the area from negative 1.1 to 1.73. So look what you can do. You can find the area to the left of negative 1.1, and this is the one that you don't want. So you subtracted it from the other area. So the area between negative 1.1 and 1.73, guys, will be area to the left of 1.73 minus area to the left. It's the bigger area minus the smaller area. And then you subtract the two answers. If by mistake, guys, you put the smaller minus the larger, you're going to get a negative answer. You know, probability can't be negative, so switch, just the two numbers. So 1.73. Let me show you the 1.73. What would that be here? 1.73. Help me with that, please. So that's a 1.7, and I need a 3. It's 0.9582. That's the first area. That's the bigger area, minus. Now area to the left of negative 1.1, because it's negative, I have to switch to the negative table. And this is negative 1.1, guys. Negative 1.10. I need negative 1.10. What is this going to be? 0 is right here. Remember, it's toward the end. 0.1357. And you subtract the two numbers to get the answer, which is going to be 0.9582 minus 0.1357. And I got 0.8225. And I'm just going to put the final answer here. 9582 minus 0.1357 equals 0.8225. This is how we use the table. Now, you guys agree with this shading. If someone asks you to explain, describe what you see this is the area to the left of Z equals negative 1.33. I told you guys area means a probability, means a percent, means a proportion. So if I want to write area to the left in another area to the left of Z equals negative 1.33, in another way, using probability symbols, look how I write it down, guys. You put probability P, you open parentheses, you put Z, and you put a negative 1.33 here, and you put an inequality symbol here. Can someone guess what the symbol is going to be? We want to go this way, to the left. What would the symbol be? It's either less than or greater than.
Less than.
Yep. You don't need the equal to, not needed. There is no such a thing called equal in the continuous case. So only less than, greater than. If you put equal, it's not wrong, but it's just less is good enough. So area to the left, guys, it means a probability of Z less than the number. And if I go here, area to the left of Z equal negative 0.47 is equal to probability of Z less than negative 0.47. So guys, I'd like you now to associate left with this symbol. They correlate, they mean the same thing. Area to the right of Z equal 1.28, which I already showed you. 1.28, let's see. There you go, right here. To the right of 1.28. You can rewrite this one using the simple probability, Z. And I'm going to the right, guys. So I'm moving to the right of the number line Z. Do you guys agree with me? It should be a greater than 1.28. So to the right means greater than. Would someone be able to complete the blanks in here? What's the relationship between a greater than and smaller than here? What we did when we used the table, we did the area to the left, which is the less than, and then subtracted from what? 1. That's what we did. And I think it was 0.8997. Area between two numbers. Here's how you write in between, guys. For example, for this is the area between negative 1 and 1. Here's how you write it using probability symbols. Look, put the Z in the center, put those two signs like that. That's in between. Put the smaller number first and then the larger number next. And in our case, guys, I have a negative 1.1 and a 1.73 right here. This one. If you want to express this using probability, look what you write. You put P, you put Z in the center, you put those two signs, and that will be the smaller number first and then the larger number. And that is the probability in between. You will find the area to the left of the first one minus the area to the left of the second one. So let me just write it down. Any questions, guys, about this? We're gonna do some more practice. I'll be doing some more practice, but I'm gonna do a quick summary here. If he asks you to find the probability of Z less than A, he is asking you to find the area to the left of Z equal A. And how do you do it? Use the table. It's called table 4. Just use the table as is. That's the first conclusion. What about if he asks you guys to find a probability of Z bigger than A? Which is area to the right of Z equals A. Can someone tell me what to do here? In words. You can say it in words and I'll write it down. What do we do, guys? We use the table, and then what do we do with the answer we get from the table?
Subtract it from 1.
Exactly. Use table 4 and subtract answer from 1. Okay. For area, probability of Z, I'm going to write it right here. Use table 4 to find areas to the left of Z equals A and Z equals B, and then subtract smaller area from larger area. Okay. Your turn, guys. I'm gonna just project one question and I project the table and have you do this. So let's do this practice here. And here is the table. So we need a probability of Z less than negative 0.56. Do you guys agree that this is an area to the left? So we just use the table as is, negative 0.56. You got to go to the bottom because the negative 0.5 is right at the bottom. So who will give us an answer? Okay, let's see what the answer is. 0.2877, let's see. 56, so I have 9876, 2877, that is correct answer. Yes. Next question. Z is bigger than 0.92. Bigger than, it's an area to the right, guys. So let me show you the 92 and tell me what you're gonna do with this. There you go. Just to give you a good feel about using the table, guys. It's not difficult. 90.92.
0.8212.
So 92. And what are you gonna do with the 0.8212?
Subtract it from 1.
Exactly. Exactly. So it's gonna be 0.1788. Next one, last one. area between z equal 0.63 and 1.63. So what we said, guys, you find the area to the left of the one number, the area to the left of the second number, and subtract the areas. As simple as that. So let's do the 1.63 first. One 1.63.
9484.
484. Okay, let me write it down. Don't forget, we have to do the next one. 163. 0.63 right here. So I got 0.7357. I just subtract the two, guys. Use your calculator. So I got 0.9484 minus 0.7357. 2127. Yeah, I've seen this answer already. And that's how you find the areas. Remember, guys, in section 2.4, now I'm going to show you that what you're learning today, you can go back and do things that you had to memorize before. Remember, guys, when we did section 2.4, we said statisticians say that 68% of the data lie within one standard deviation of the mean. What we're going to do now, guys, we're going to see if it is exactly, we're going to figure out whether it is a 68% or not. I asked you to trust me at that time that this is a true theorem. Let's do this and see if we'll get 68%, guys, using the table. Remember, this is negative 1.00 and this is 1.00. So let's see, find the area to the left of 1. Okay. What is 1.00? That's a 1.0 and that's a 0. So you guys see 0.8413. Let's write it down. Minus negative 1. Let me just take it to the negative 1 now. Negative 1, guys, it's right here, negative 1.0. And can someone tell me what the area to the left of negative 1?
0.1587.
Okay, so there will be 0.1587. I agree. Let's subtract, guys. Let's see if we're going to get the 68%. If we don't get the 68%, it has to be close to it. Doesn't have to be exact. I said about 68%. 8413 minus 1587. Watch, guys. Change this to a decimal, to percent. It will be 68.26%. And in section 2.4, the empirical rule says about 68%. Here you go. That's about 68%. So you don't need to memorize the empirical rule anymore because you can do it. All right. So this is how we do find areas to the left of a z-score, to the right of the z-score, between two z-scores using tables. Now we're going to come to how to use technology in doing this.